All right. Looks like we have a full house, so let's get started. Welcome, everyone. Thank you for joining us for today's webinar entitled Introduction to Prescriptive Analytics, Solving Real-World Optimization Problems using ILOG CPLEX Optimization. My name is Nabil Nazir. I'm a Senior Account Manager at Newcomp Analytics, and I will be your host. We have a great session lined up for you today, and we hope that you will find the presentation informative and useful, regardless of where you are in your analytic journey. Our hope is to share our knowledge and best practices with you so that your organization can benefit from them. Okay, so if you can just go one slide before that, please. Yeah, perfect. All right, so before I introduce our speaker, I'd like to cover a few housekeeping topics. Today's webinar is being recorded. We will be able to share a link with you to the recording as well as the presentation slides after the event is complete. We welcome you to revisit the content yourself and share it with your colleagues. We also invite your questions and comments. Please look at the questions chat box within the control panel on your screen. If you think of a question for the speaker at any point, just type it in the questions box and I will pose it to our speaker at the end of the presentation. For those who are just joining us, welcome. Next slide, please. All right, so once again, before I introduce the speaker, I'd like to introduce Newcomp Analytics. We are a dedicated analytics practice with over 400 successful project implementations and satisfied clients across Canada, the US, and the Caribbean. We focus on what we call the 5 pillars of analytics, and those include business intelligence, planning and forecasting, advanced analytics, which includes predictive analytics and prescriptive analytics, which we'll be covering today, information management and governance, and open source analytics. Lastly, as an IBM Platinum Business Partner, we provide a suite of value-added services, support, training, and education for IBM solutions. Next slide, please. Okay, so I would like to take a few minutes to introduce our presenter. So our presenter today is Alkis Vasakopoulos. So Alkis is a business analytics and optimization expert. From January 2008 to January 2011, he was vice president at FICO Research. Prior to that, he was the president at Dash Optimization, where he worked closely with end users, consulting companies, OEMs, ISVs in developing optimization solutions. He also does consulting work with Fortune 500 companies in the areas of finance, marketing, optimization, data mining, supply chain, retail optimization, procurement, and decision analytics. Dr. Vasakopoulos is a pioneer in using parallel programming for solving large-scale optimization problems for several verticals, particularly in banking and retail industries. Alkis has an ERDOS 3 number, and he has co-authored 4 major publications with Dr. Egon Ballas, and his dissertation paper, Guided Local Search for the Job Shop Scheduling, has more than 300 citations. A very accomplished resume, to say the least. And with that, I'd like to hand over to Alkis. So Alkis, over to you.
Thank you, Nabil, very much for the introduction. Okay, so let's go to the next slide. So today I'm going to focus more on prescriptive analytics, but at the same time, I'll give you some framework how to connect with descriptive and prescriptive analytics and machine learning and AI technologies. I'll try to focus on optimization. This is the word. What you hear today mostly is AI, a lot of machine learning, visualization. So I want to bring again optimization and see how all these connect together, okay? So the first thing I want to do is I want to show you an old slide. It's old these days. It's from a book by Steve Sasisara, which is called The Optimization Edge, that was published in 2011. It's kind of old, but it's not old at the same time. On the left side, you see companies like UPS, Amazon, McDonald's, Walmart, Marriott, and Google. And you realize what is the difference between the companies to the right. And most of the companies to the right, they're struggling with the prescriptive, and with their machine learning, and also they try to implement new technologies, but they never develop optimization technologies seriously. Some of those companies, they now are out of business, like Borders. Yahoo got sold. Airborne Express has been really in the background. UPS, if you see the cases, UPS applies optimization in most of the strategic applications. Amazon also applies a lot of optimization. McDonald's, Walmart applies optimization in many problems. Marriott and Google. Okay, so the main difference between the two these two categories is that the companies to the left, they really apply optimization. There are many use cases for those companies. Now, usually the difference that we see today with machine learning and AI and predictive analytics is for optimization problems. We have methodologies to evaluate the benefits. And these are some cases where in the past CPLEX has been applied. And you see, you understand, you know about those companies, like UPS. They have applied optimization in air network design, and these are the savings. South African Defense, they apply in equipment planning, and these are the savings. Motorola, procurement management, and these are the savings. So on the one side, you see the companies. On the other side, you see the applications. And here you have clear benefits. So with optimization, it's simpler to understand and to calculate the benefits because they are, they affect your real KPIs. And those results come from Edelman Award. This is a famous award that the Inform Society is awarding every year, and there are papers for all this. So, we can research and we can get you papers that they show the application that they applied and the savings and the methodology they use. So optimization has hard benefits, correct? So you can calculate your return on investment. You can, some of these applications, you have payback per month. You automate an application and instead do it by hand. You can do it, using CPLEX. And, in sometimes even weeks, you can get back the money from optimization. You reduce the capital expense. You have operating expense reductions, and you increase the total revenue and the revenue mix. Also, optimization is used to improve the customer satisfaction, improve the customer service, and provide better and customized service, and also improve operations. So better planning, minimize cost, minimize profits. So these are the hard benefits of optimization. Now, what is decision optimization? If you look at the IBM Advanced Analytics portfolio, you have basically, you start with descriptive analytics, which is basically Cognos, and the other descriptive tools like Watson. You go to predictive analytics, which is Watson Studio, SPSS, SPSS Statistics, SPSS Modeler, and then you go to prescriptive analytics, which is the optimization that we'll discuss. So descriptive is going to tell you what is happening to my business today. You're going to get your insights. Predictive is what will happen to the future. And then prescriptive is going to help you understand what you should do to improve your operations, to use the information you have collected before to do optimization. So decision optimization is kind of secret. These days, again, the focus is mostly on this and AI, but still, many of the customers, they start projects in prescriptive analytics. So again, if you look at Thomas Davenport paper, basically when you apply the descriptive, predictive, and prescriptive, basically you go and you increase complexity on the problems you solve, but at the same time you get competitive advantage. Okay, so that's from the book by Thomas Davenport. That was back in like 2004, 2005, and optimization is somewhere here. This doesn't mean that you cannot apply optimization without all this. Okay, so you can jump and do optimization projects and stochastic optimization. I bet you are doing some predictive modeling, you're doing forecasting, you're doing statistical analysis, and of course you have built within your DB, your warehouse, you have built SQL and standard reporting and alerts. Again, there is no reason to have all this to move to optimization. You can do proof of concepts today, and you can start early with optimization projects. But this is basically the framework. So the idea, yes, you're moving there, it's more complex. But if you have a real problem, you can jump to optimization, do your forecasting, feed your results of the forecasting to the optimization. So again, the applications we see for the decision support applications we see is that in order for you to mature, you are starting from historical and master data, and you're here, you're capturing the price, the location, you're doing your predictions, you are creating the rules and the project management, process management, and then you start, collaborating, and you're developing your what if analysis, and you create multiple scenarios you want to run, and then the decision, making. You're trying to make decisions automatically. So again, you move from prescriptive to predictive, from descriptive to predictive to prescriptive, and this is kind of a framework for a mature organization that uses all these technologies. So you are going to ask me, okay, give me some examples of verticals that they use optimization, and that they're doing them today. They've done them the last 20 years, but they still do them, and what problems companies solve today, especially with the advent of machine learning. So what I'm going to say, there are 5 verticals that I have here. I'll start with communications, like telecom companies. Media, advertising scheduling is one. We've done many applications there. At sales proposal generation, in the media, this is again advertising. Energy and utilities, you have smart grid. Many applications in water network design. Distribution is a very important area, especially now with all the tariffs and what is happening. You have in consumer products, you have production planning and scheduling, network, production sourcing, inventory optimization. In retail, again, network inventory, product flow optimization, warehouse replenishment, workforce scheduling in retail. So when you go into a supermarket, you see part-time employees, full-time employees. This is workforce scheduling. Workforce scheduling in a hospital, same problem. Travel and transportation, you want to improve your assets. Trains, you want to empty, you want to have container repositioning. The same thing with trains and large containers. Financial, many problems today. Problems in banking, cash management, campaign optimization, portfolio optimization. Financial services, trade settlement. We have companies that they do this every day. They try to settle the trades. Industrial, of course, sales and operations planning, S&OP. So here the buzzword TM1 and how you would use TM1 with CPLEX, sequencing and slotting, how you will do this. aerospace and defense, master production scheduling, project scheduling, line balancing, electronics, in chemical, hundreds of applications, network and inventory optimization. And again, you have in public, like nurse scheduling, production planning, network and inventory optimization, and government, again, network and transportation planning. So you see there are hundreds of applications that and opportunities for large or small companies to use to start doing some optimization. So again, this is I'll give you some examples of the companies. So you have this Mexican Securities Depository. The challenge is to process the security transaction in real time than daily and provide a better service to the Mexican exchange. Again, decision optimization was the solution, and that's an assignment and scheduling problem. The benefits of this, it was first of all real-time reconciliation and completion of the trading operations, and this is $250 billion in the average every day that they will be settled by CPLEX. Reduced liquidity requirement by 52%, and increase the volume operations, so that means more transaction costs for the company and the securities depository. And so reduce costs for electronic trading facilities for the stock exchange. Again, this company was a private securities company. They won the Edelman Award for this. And, they built one solution and they were very successful. So this is something that is running today. Now, again, tax, okay, this is, this is again an interesting one for the New York State. The challenge was that you have some questionable tax refund, and 98 exception returns are processed, and they had many people to analyze the exceptions. By doing, business process management for the automation, SPSS for analytics and decision optimization for the assignment and scheduling. So what you achieve here, you achieve better assignment of the returns to the right auditors. You can increase collections by 83 million. And you can, by assigning to the right field agents, you had you can decrease the average age for case by almost 10%. So basically what is happening here is you are using SPSS to do the predictive modeling scoring of the returns, and you use decision optimization to do a very clever assignment. Okay, so you can do this very quickly, and that's the profile of the company. And again, here, this is the customer. The challenge here was to place order for a flash memory from manufacturers. Determine how much memory will be used, which product line. So basically, here you were freezing for 4-week period, and you didn't have flexibility, and you have constant changes in the market. So the solution, the Excel spreadsheets, they replaced by optimization solution for the supplier planning. And the benefits are the team now can collaborate, can make better decisions, and they can look at all plans. So this one is not, there are many companies in that area that they do something like this. Again, Airbus, the challenge was they had increased complexity in the final assembly line. They had, the market demand was volatile, the tough competition from Boeing, there was pressure on costs and time delivery. They need to increase the productivity utilization. What is the solution? With ILOG optimization, the solution now is on scheduling and monitoring and rescheduling the production. And that one goes with SAP. And you provide an executable schedule in minutes to plan the activities, correct? So the benefits is that a unique tool that you can do this and save money, and again, the planning reduces from 7 to 3-4 hours. Now, if you now you're going to ask, what are the tools that we have today? So we have tools that they differentiate us from the competitors. We have CPLEX, and CPLEX has a full range of solvers, linear programming solvers, mixed data programming solvers, constrained programming solvers that nobody else has, and we can model those complex problems. We also provide this in the cloud and as a service. So we have both the on-premise and in the cloud tools, and we have modeling tools that you can model and start building your applications. So again, if you want to, many of you probably have TM1, and you have in TM1, so how you are going to visualize this life cycle. You're going to import your historical data with TM1. You probably are going to do some SPSS, and determine the demand. This is not necessary. You are going to review and edit the forecast in TM1, and they're going to create multiple what-if scenario, and then they will use decision optimization to build now plans. This is for like scheduling problems, production planning problems, SNOP problems, and again feedback those decisions back to TM1. So that shows you the life cycle with TM1. So again, here I have a different visualization of the problems, and in marketing, like sales, finance, IT, operations, HR. Right now, if you're in HR, you want to retain your employees, so you want to optimize your compensation, the training, and the planning. That's the problem you have. In the operations, you want to have, to provide warranty and to do analysis. The problem you need to work is the sales and operation planning. If you are in IT and you have a help desk, you need to do staff assignment. That's the optimization problem. If you are in finance, you want to prioritize the accounts receivables, so you will do portfolio optimization. If you are a pharmaceutical and you want to do sales, you want to retain your customers, you will do territory optimization. If you are in marketing, you are going to do return on investment analysis, and you will do some planning. This is the descriptive model, and this is the prescriptive model that you can look at the line of business, and these are some typical use cases. So again, so in this example, Bridget is a sales manager. Here, descriptive problem is that what is the revenue in every region. So it's going to go to Cognos, and it's going to visualize the revenue. If she wants to do predictive analytics, it's going to say what are the predictive sales per region. So it's going to predict the sales. And when you do prescriptive analytics, the problem is going to be how should I create territories and assign them to the salespeople to maximize my quota. Okay, so you have a complete view of a specific problem that can be applied for pharmaceutical, electronics in the sales type of problem. So, so in this one, this is like, the prescriptive analytics. That's where we can provide value for this type of problem. Some, if there is a lot of discussion. That's why I'm bringing these slides. And many people ask me, what are the difference between machine learning and optimization? Can you point out, some difference? And I will give you this slide, and it's a very interesting one. In machine learning, you have historical data. You send it to machine learning. You send it to a machine learning model, and you can score or create a predictive model, correct? And get insight, get prediction. So, you know, the problem might be a customer A is about to churn, is going to give you a score. Customer B might need product C, you know, what is the probability or propensity to get product C? You know, here you only need the data, and right now you can put them in Python using Watson Studio, and you can use even auto modeling techniques that Watson Studio has. And this is, you know, today's environment, it might be even completed automated process. In decision optimization, the problem is more complex. You know, the forecast that you will get from here is going to create, you know, it's going to feed a decision optimization model to create a plan. You have to spend more time in creating the model. You don't have the flexibility and, you know, of these machine learning solvers. The solver is here, but we have to do some extra work to put the constraints, to put the variables, to decide all these things, but you make more money, saving more money in this area, and you might do more automation. So this process might change very rarely, because now you have a steady model that you apply. You know, in here, you know, the competitor is doing the same thing. You might need to change your machine learning application. So, you know, the decision that you will get here, you send the proposal Y to customer B. So this is basically a decision that you will get from the decision optimization. Again, today's environment, you have transportation problems. So, you know, you have traffic, weather, past trips, and that might be the data that you pass in a machine learning model. So basically what you want to do, many companies now, they forecast the demand from customers and the travel times, you know, based on the traffic, the weather, and, you know, past experience. And they're going to send it to decision optimization. They're going to use the policies, the capacities, the actual demand, and what you're going to get the routing plan for, you know, so that's what UPS is doing. Again, that's what FedEx is doing, but Staples is doing it. You know, there are many other companies that they now start combining machine learning with optimization to get a lot of benefits. Now, in insurance and fraud, this is a lot of applications here in the machine learning. You know, you have past claims, you have weather patterns, you have the customer class, you have the claim case, if it's a house, a car, another device, and now you can, you know, you can use machine learning to understand and forecast your claims, or understand if a claim is fraudulent. How you're going to use decision optimization. Decision optimization, you're going to use it. You're going to use this information, combine it with decision optimization, and you're going to use the actual cases you have, the skills of your agents, your capacity, and the routing, how you will send them from one to another and create a schedule. So now you're more clever, you know, to assign the right case to the right person with the right skills. So there are many insurance companies that they start using now decision optimization combined with this area. So in finance, you have market behavior. You know, you use machine learning. You know, you have different scenarios, scenario 1, 2, and 3, and then you have budgets, you have risk, you have rules, and commission fees. You build scenario and you build portfolios. Mostly today, most of the applications are in decision optimization. They don't use a lot of machine learning. They use predictive, like variance and risk, but not a lot of machine learning, but they're moving in that direction. And of course, in manufacturing is you have, you know, your customers, correct? And you have the order durations, and then you have lines and the recipes, and you have line 1 and line 2, and you create a production schedule again, where you will use there are many applications today for optimization are in in preventive maintenance, which line is going to break, and you want to you don't want to have disruptions. Okay, I will give you a very quick application of how you will do retail optimization, and use like a TM1 framework, predictive and prescriptive, and what types of problems each one is going to address. Correct? So here you see every day, you see promotions, clearance, markdowns, price points in every store that you visit. Now, what is the use case here? The vertical is retail clothing. The products are apparel and some accessories. What are the objectives? Is to maximize revenue, maximize margin, and reduce your inventory. The decisions, basically, you want to do some kind of dynamic pricing. What do you have on hand? You have your initial plan, and what do you want to do every week? You want to review. You have many stores, and you want to decide what's going to be the pricing, dynamic pricing, what you're going to put on a markdown, the price point. Some of them you will put the clearance, and what promotions you're going to have. And you see, all of these are different decisions that a retail company is going to address, has to address. So again, if you are in a TM1 environment, what's going to tell you is that what do you have? Probably in your cube, you have your sales, and this is your plan, and this is the units that you need to sell, and this is the margin that you want to have for the for all your sales. So to remain kind of break even and make money. That's your revenue. That you can get it from your Excel, or of course, if you are more sophisticated with tools like TM1. What happened in practice in this week? We got the actual sales of less, like we missed by 600,000. This is an example. We sell less number of units, and we sell the margin wasn't very good. That's what happened last week. So this is the actual, and this is the target. The plan. So we missed both in sales revenue and units sold and margin, so it looks bad for the CFO and the CEO. Now, again, what you will do, the next simplistic thing you will do is you're going to ask, which season was the problem? So, or which seasons were the problem? So what we found out here is that the spring season 2016 is the problem. We missed by $1 million, and we missed by 40,000 units, by 50,000 units almost, and our margin was okay. So we missed on revenue and on units here. So again, this information you can get it from TM1. So using TM1 analytics, what you will get is that you will get this variance from the plan and the actual. But now that we know this, we're going to look forward, and we're going to say, okay, how can we affect the demand? The only thing to affect your demand is by doing promotions, markdowns, and clearance. So how do we decide which product groups where we need to act and when to act? So here you have predictive analytics and prescriptive analytics. So using predictive, what you can do is you want to predict the sales for next week or weeks. You want to identify the slow and fast moving items, products, and also you identify what those products that they're going to react well in markdowns and promotions. So these are 3 action points that you have, and you can do them easily now with SPSS statistics or SPSS modeler. Now, using prescriptive analytics, what we're going to see is that we're going to decide what is the optimal prices that are going to maximize. Having this information is going to help us a lot with doing optimal pricing, and we're going to decide when we're going to offer the promotions to maximize our revenue. So here there is a clear path of two types of areas, predictive and prescriptive, and what problems we can solve today with this. Again, the data that we need for here are on the SKU level. So like, what revenue have achieved from a specific SKU, what margin we have. By having this information, we can use it on SPSS modeler and make a decision that it's individual, or we can solve a more complex problem that takes groups, families, and I decide about what promotion we want to do for next week. So we can do this easily, and we can use optimization using that information and decide areas where we can start doing some kind of markdown. And this is for like slow moving items, at times that they become slow. And, because we want early to promote them, to get rid of them, to decrease our inventory and increase our revenue. So using CPLEX, we can decide moving forward how we'll do a plan like this. This is a fast moving items, and you see I promote it later on in like week 10. And, my markdowns are slower because this is a fast moving item. This is items that I can sell quickly. So the transparency when we give you the PowerPoint, you will see some, benefits that you get if you do markdown or if you don't do optimization. Now, the key point is that using predictive analytics is that, where you're going to use it, for every SKU, you're going to decide if this SKU is a slow moving item or a fast moving item, and what is going to happen in the future. We can do this very efficiently, but also the second dimension is going to be, you can understand if it's a slow moving item and you put it on a promotion, what is going to be your sales lift. And in this is a very bad scenario, it's a slow moving and you have sales. So if you have ordered a lot for this item, then you are not doing well. You're doing well here, but maybe you don't want to mark down some of these because, they sell well. And also maybe you don't want to put those on a markdown. So that's, using predictive, getting these insights is pretty important. So again, these are different scenarios of how you can maximize your revenues. And again, we're going to provide you with these so to summarize, you saw, what we provide to you today is an idea about types of problems you can solve, vertical areas, you can apply it. We show you a connection with TM1 and how you can use TM1 to integrate and to create a life cycle, and also with SPSS, Watson Studio, and the IBM portfolio of analytics, complete tool. And I show you a use case, very simplistic use case for retail. So I think now, Bill, do you want to talk about the next steps here, and we can go to questions?
Yeah, absolutely. Thank you very much, Alkis, for the presentation. So just a couple of call to actions here. So you've seen the presentation, you've seen the art of the possible with decision optimization and the different use cases that Alkis has outlined. So the next step is really for you to folks on the line to connect with us to discuss your current use case and where you see optimization might add value to your organization. And we can obviously help you out from a proof of concept perspective. So we can help you with the current data set that you have, do a bit of a proof of concept within IBM ILOG CPLEX Optimization Studio, and essentially just showcase the art of the possible, with a solution like that. I mean, Alkis has really outlined, some of the case studies and, the value that decision optimization has brought to different organizations. And so if you have any interest in digging a little bit deeper into that, we will be sharing the slides with you, and we'll be sharing the recording with you. You can let us know, and we can set up calls with you and walk you guys through some proof of concepts and just discuss your use case. I don't see any questions in the question box. So with that, thank you very much, everyone, for joining us this morning, this afternoon, wherever you're located. And have a great day. Thank you, Alkis. Thanks, everyone.
Thank you.
Bye.
Thank you.